Hi everyone, we're going to pre-record this so that we don't have any of the problems we had this morning. So we're going to move on to factoring the whole story. Okay, so up to this point you've seen factoring where you had, for example here, something you could common factor out. And then once you common factored out that something, so here's our exercise from earlier. If you common factor out the 2, right, what are you left with in brackets? You're left with x squared plus 2x plus 1, right? That brought the 2 out of every term. But you were left with something in brackets here that had a 1 out front of the x squared, which for us is called a basic trinomial. So at this point you could basic trinomial factor. So right now we're going to learn what happens, or what do you do when you can't get this to work. So when you can't get 1 out front of your basic trinomial, you can't get a basic trinomial. Okay, so when do we use the criss-cross method, as we call it? Use it when we still have an a larger than 1 after common factoring. Okay, so what happens if you still have a number here even after you common factor? Okay, here's an example. So what you see here on the right is a non-example, right? This is not an example of when we use the criss-cross method because we can use our easier method of factoring. When we want to use the criss-cross method, what we want to do is look at our quadratic and say, I can't common factor anymore, and there's still a value of a out here. So you see here, I cannot common factor anything because 3 is not common to 10 or 7. I can't divide 10 or 7 nicely by 3. So it looks like I have to use the criss-cross method, right? There's no common factoring here. In the future, however, you may need to common factor first, and if you can common factor, do common factor. So the first thing to do would be to common factor. If you can, okay? The next step, once you common factor, is to find all factors of A and C. Okay? You're going to make this into a table. So I'm going to make a table here. I'm going to make the table with a 7 here and a 3 here. And it's a rather elongated table, but that's fine. What I want to do is I want to find all different pairs of factors. So 1 times 3 gets us to 3. 1 times 7 gets us to 7. Okay? So I want to find all pairs. All right? When you're finding these pairs, all right, 3 and 7, they're prime numbers, so there's not too many pairs, but there could be more. You would write all of them down. So if you had 60 here instead of 7, you'd continue with more pairs. So for example, 2 and 30 or 4 and 15. As well, this is a lot similar to what we were doing in order to factor here, coming out with factors of 1, right? In order to factor here, we had to find the factors of 1, okay, which weren't that many. And this told us pretty quickly what we needed to put down inside the brackets. So we're going to do basically the same thing here, right? These are going to help us determine what we need to write inside our brackets. Okay, so I know that I'm going to write a set of 2 brackets. Okay, so what is it that I'm going to write in these brackets? All right. What we're going to do next is find a combination. And this is why they call it in criss-cross method, either find a combination in an X or a straight across. Okay? What I mean by that is either you multiply 1 by 7 and 3 by 1, or you multiply 1 by 1 and 3 by 7. It depends on what you need. Okay? When you multiply these pairs together in such a way, either by crossing or with the parallel lines or with the crossing lines, what you want to do is you want to, when you multiply them, for example, 3 times 1 and 1 times 7, if you add them together, or if you subtract them, you should get to your B value. Okay? I'll write that here as well. Add or subtract combination to get the B value. Okay? So as it happens, for example, if we did this parallel line combination, think about what that gets us. That gets us 3 times 7 and 1 times 1. So that would be 3 times 7 is what? 21. And 1 times 1 is 1. So that would be either 22 if you add them, or 20 if you subtract them. Neither of those is close to negative 10, or the value 10. So it's not going to be the parallel line. I only have one other option. So it must be the criss-cross. Okay? So 3 times 1 is 3. 1 times 7 is 7. If I add those, that does get me to 10, but I need some negatives in here in order to get to negative 10. In fact, I need them both to be negative, right? I need negative 7 and I need negative 3. All right? These numbers that create your 3, they're going to go out front of your X. Okay, so X is here, right? And we're going to have a numbers out front of our X now. All right? So these numbers go there. You can put them in either bracket, okay? It doesn't matter. So I'm going to put, I guess, 1 here and 3 here, okay? What matters is where we put the 1 and the 7. So 3 needs to get multiplied by the 1, which means I have to put a 1, and if I color code this, I have to put a 1 in the first bracket here. So I have to put 1 here. That means I only have, by process of elimination, I have to put the 7 somewhere. It has to go here. But just to verify, that 7 has to get multiplied by this 1. So this 1 is here. It has to be multiplied by this 7. So that means they have to go in different brackets. Okay? If we want them to be multiplied together, they have to go in different brackets. Okay? Now we have to decide how to get negatives and positives. Well, let's use all the information we have at hand here. I have a positive 7 here, which means either they both have to be positive or they both have to be negative to get a positive 7. If I want that positive 7, but this negative 10, well, since I need that negative 3 and that negative 7, it looks like I need both of these to be negative, right? That would ensure that I have a positive 7 here when I expand outwards again, and that when I multiply this 3, right, the 3 times the negative 1, I get negative 3, and when I multiply the negative 7 by the 1, I get negative 7, and when you add those together, you get negative 10. Okay? And there we have our factored form. So I'll write that a little neater. X minus 1 and 3x minus 7. All right? There is another method to doing this that is a little more similar to what you've seen before, where we were multiplying to get one number and adding to get another. I've posted a video of this method already in our living document. You can go there. I'll also link to it when I post these videos. Okay, so you can see the other method, which I think some of you might like more. but this is the criss-cross method. Let's see another example. Okay. At any point, pause the video if you need to. This might be a good point to pause and review this example. Let's see if we can fit everything in this screen here. So now I have another one here. I'll see if I can common factor, right? My first step was to common factor. Divide 36 by 5. Not going to happen, not nicely. So it looks like I cannot common factor. So what I'm going to do, I'm going to create a table. 5 on this side, 81 on this side. I'm going to have 1 and 5. And, 81 is, I guess there's not that many options, but there's a few options here. I could have 1 and 81. I could have, the next one I can think of right off the top of my head is 9 and 9. You know, in terms of other options, what do we have? I think I've got 27 and 3. And do I have anything else? I think that's it. If you can't think of all of them, possibly that's okay. Okay, think of as many as you can, as many factors of 81 as you can. So what we're going to do is we're going to choose one of these sets of factors, right? Either that one, this one, or that one. We're not going to choose all three. We're only going to choose one set of factors. Okay. And it's a bit of playing around. So let's just say that I don't think this is going to be successful, right? Because we've already got 81 here. So if I multiply 5 by 1 and 1 by 81, I'm going to get 5 plus 81. That's going to be bigger than, way bigger than 36, right? And not get anywhere close to 36. Or if I multiply 1 by 1 and 5 by 81, this is going to be huge, right? And then we're only going to be subtracting or adding 1, not anywhere close to 36. So I'm going to rule this one out. The same can be said of this last pair here. So 5 times 27 gets us nowhere near 36. However, 5 times 3 is 15. 1 times 27 is 27. So 27 plus 15 is not going to be 36. And 27 minus 15 is not going to be 36. So, okay, this isn't going to be a combination either. Right? And that was the common sense one, because if you did 5 times 27, that was large, right? 1 times 3 is small, so probably not the criss-cross method either. So we're going to rule this one out. So either we've got a straight across line here, or we've got a criss-cross. Well, actually, it's the same, the straight across or the criss-cross. So let's go with criss-cross, I guess, again. Doesn't really matter because they're both 9s, right? So it doesn't matter. So I'm going to have 1 times 9 and 5 times 9. Okay, let's just double check that this is going to get us where it's going to go and what we want, right? So 5 times 9 is 45. 1 times 9 is 9. While 45 minus 9, that will get me to 36. Okay, so good. I'm at 36, so that's good. That means this is definitely the combination I want. There's not some other combination I have that I haven't found yet. This is definitely the one I want. So I will write out my brackets. And I know it's going to have this shape, right? I know there's going to be sets of 2 brackets. And I already know that 1x and 5x go here. I just need to decide the negative or positive 9 and 9, right? So I know, actually, I know more than that, right? I know 9s have to go here, right? Because they're both 9, okay? So this one's a little easier because it's we don't have to decide where the 9 goes. But this 1 gets multiplied by 9, which is going to happen, right? 1x times 9 and 5x times 9. That's going to happen. The multiplying is going to happen. I have to decide which is going to be negative and which is going to be positive. Well, I need a negative 81, which means 1 has to be positive, 1 has to be negative. If I had 5 times 9, that would be positive 45. And if I subtracted 9, that would be positive 36. So I don't want the negative 9 with the 1 and the 9, right? Because that would get me to positive 36. I want negative 45. So that means my 5 times 9 has to be negative, which means here's my 5, and it's being multiplied by this 9. So that makes this 9 negative. Okay, and by process of elimination, this one has to be positive. All right, and there you go. There it is factored. Let's go over another example. Again, here I'll look for anything to common factor. 2 does not divide 9 nicely. Neither does it divide 81 nicely, so let's not try to common factor. So I will write out the factors of 2 and the factors of 81. So the factors of 2 are easy. They're 1 and 2. I already have the factors of 81, so they're 1 and 81, 9 and 9, and 27 and 3. Right? So once you get a little practice, you'll know factors pretty quickly. I'm going to guess it's this one again, honestly, right? Mostly because, look here, I want -9. Let's just try it, right? Let's try this one first, so maybe we don't have to waste time with the others. If I use my crisscross method, it doesn't actually matter if it's crisscross or parallel lines there, because these are both 9. So 1 times 9 is 9, 2 times 9 is 18, and 18 minus 9 does get us to 9. And it looks like I want -18, right? Because I want -18 plus 9. That's going to get me to -9, right? So I want this one, the result of this, to be negative. So maybe I want this one to be negative and this one to be positive, right? So we can kind of think ahead a little here, right? Where's the negative going to end up? Where do I need the negative? I need -18, so I get more negatives than I have positives. I'll add 9, and then I only get up to -9 after that. Okay, so this one should be negative, this one should be positive. Well, let's write out our brackets. I know it's going to have this shape. I know my 1x and 2x are going to be here, right? So where are the 9's going to be? This one's going to be 9 here and 9 here. Let's just confirm 2 times -9, which means that the negative has to go in the bracket, which is not the 2x bracket, has to go here in the 1x bracket. Okay, and then I also need a positive here because they need to multiply -9 and 9 need to multiply to get -81. So I know this has to be positive. Okay, if this is negative. All right, there's our third example. What I'd ask you to do is pause the video and try these examples right now for yourself. Okay, 5 and 6. I will continue to take up these examples in the video, but I will not explain them as elaborately as I have been with the other examples, okay? So pause the video now and complete these on your own. Welcome back. So what we have here is 3. We want the factors of 3, and we want the factors of 20, which are 1 and 20, 2 and 10, and 4 and 5. I think that's it. I want to find a combination, either using straight across or crisscross. All right, well, I want to get to -16. How am I going to do that? I'm just looking at them and I'm just kind of deciding in my head, you know, 10 and 6. Yes, that will get me to 16, right? But I was also looking at, you know, I kind of skipped over this one because I don't trust that one, but you should try that one too. I was also trying, you know, 1 and 4 and 3 and 5. What's that? 15 plus 4, 19? No. 15 minus 4, 11? No, that's not going to work. 3 and 4 is 12, and 1 and 5 is 15, so that's close at 17, but not 16, and subtracting isn't going to work either. So basically you're just playing around, right? You're playing around until you find 3 times 2 is 6, 1 times 10 is 10, and that will get us to 16. Okay? More than that, since they need to get to -16, they both have to be negative because we want the positive 20 here. We want -2 times -10 gets you positive 20, and we know they both have to be negative, so we get that -16 when we add them. All right, so actually fairly straightforward, I think, I hope. 1x, so these are just our numbers out front with our 3. 3x. and then we know both of them need to be negative, so I can just write in here negative already. Now I erased that 2 because I wasn't totally sure that that 2 was going here. I need to double check that. So the 2 needs to be multiplied by the 3. So yes, it will have to be in the opposite bracket from the 3. Okay? And that means that the 10 goes here. So this means that 3 doesn't get multiplied by 10, right? If they're in the same bracket. So we don't end up getting 30. We only end up getting 3 times 2, which is 6.